Okay, so a student had a question about discrete or continuous, and it's kind of a difficult idea, a very subtle idea, the difference between a discrete random variable and a continuous one. And I used to have an active learning assignment, an ALA, having to do with that. In the online format, we are that one kind of this one got crowded out, but I do have this ALA, so let's go through this, and I'm sure that by the end you'll have a lot better idea of how to determine whether your variable is discrete or continuous. Imagine that you are a bot and you can count all day. Emphasis on the word count. Suppose that the things you are counting are numbers. They could be numbers. Suppose they're numbers. You are presented with some set of numbers. Very big set. You can count them all day. Might even be an infinite set, but we'll just assume a finite set. If you, Alejandra the bot, can count the numbers, the variable which generated the numbers is said to be discrete. If you can't count the numbers, the variable is said to be continuous. So that happens too, doesn't it? You could have a set of numbers, the set of all real numbers, for example, between 0 and 1. You cannot count those. There are uncountably, infinitely many of them. Okay. Square root of 2 over 2, any fraction you can come up with, 1/2, square root of 2 over 3, square root of 3 over 3, all kinds of irrational and rational numbers, uncountably, infinitely many. It's not like you could just count them and then make progress toward counting all the values and then you would have a countably, even if it were a countably infinite set, but let's say a countably finite set, it's not like that for this all reals between 0 and 1, or just all real numbers. That would be a simpler example, all real numbers. Okay, so the difference is the difference between being countable and being not countable. Discrete numbers a set of discrete numbers is a countable set, and the set of continuous numbers is uncountable. Said another way, the set of discrete numbers, I've heard it said this way, is those are numbers that are counted, but the continuous numbers those are numbers that are measured. So counted versus measured. Okay, so let's get some reps here and identify discreteness or continuity, continuousness of these variables. Determine whether the following variables are discrete or continuous. Number of phone calls received by a 911 call center each day. Well, you can totally count those, can't you? You can count them, even if it seems like there are infinitely many of them. If you had to, do that job, um, you can count them. So you've got discrete for this variable. Systolic blood pressure readings. Let's make this clear by taking the word readings out of there. Systolic blood pressures. Well, those, you can't count all the blood pressures that people have. So this is a continuous variable. The blood pressure can be any number between, I don't know what the bounds are on that, even though every one of my students probably does. Weights of the suitcases of airline passengers on a specific flight. Well, this can be measured. It can't be counted, but it can be measured. So this is also continuous. Okay. Votes received by mayoral candidates in a city election. Those can be counted, so discrete. Number of students, we already know it's discrete. It's number of students. You can count students. Number of students in mathematics classes during the fall semester at your school for a particular school year. Discrete. Temperatures at a seashore resort. Can you count all of the possible temperatures? No, you cannot count all the possible temperatures. This is something like the set of all real numbers between 70 and 100. There are uncountably, infinitely many numbers in there. This is something that is measured. And so this is continuous. Basically, whenever you have temperature, it's always going to be continuous. Another one like that is time. If you ever have a time measurement, the variable is continuous. And so we see what all of these have in common: the continuous variables and the discrete variables. For the discrete variables, they can be countable. The other ones, and this one too, number of students, you can count those. But the other ones can't be counted, but they're measured. You wouldn't even try to count all the temperatures, right? They are something that you measure. Something you count, something you measure. You measure time, you measure temperature, you measure blood pressure, you measure weight, you measure height. So do you count it or do you measure it? Goals scored. That's something that you count. So it's discrete. Volume of water. That's not something that you count. That's something that you measure. Continuous. We talked about time, and time is always something that you measure, not something that you count. So continuous. Continuous. I'm writing it out because the word continuous, if you abbreviate it as cont, then it looks like count, which would make it discrete, but it's not. Number of trees, number of sequoia trees, you can count that. Discrete. High temperature. Well, we already talked about temperature. There are only so many examples. Something you measure. Continuous. Internet connection speed. That's something that is measured. And so something, a variable, the variable, what is the speed? Something that varies. So what is the speed? Continuous. Points scored, you can count them. For some players and games and teams more than others. If it's Texas A&M, it's really easy to count them because there aren't that many of them. Points scored in an NCAA basketball game, you can measure, you can count those. Discrete. Air pressure. You can't count air pressure. You can only measure it. Continuous. Numbers of people surveyed in each, well, that's a countable variable, number of people. You can count it. Discrete. Exact foot lengths. That's something you measure. Something you measure. Continuous. Exact times that randomly selected drivers. Well, we said times. Those are always continuous. There's something that you measure. You measure time. You don't count time. You measure it. It's a continuous variable. Okay, so I hope with all these reps, you've gotten the rhythm of looking at a variable and determining whether the variable is discrete or continuous. Thanks for watching.